Copy that. Can't wait for the big show.
I try on an actual spacesuit. It's the ultimate protection against the deadly hazards of space.
T-minus 25 seconds.
I train with real astronauts by sitting still in a chair while the room tumbles around me.
T-minus 20 seconds.
I go to NASA to visit the next giant space station. What will it be like to live in space for 6 months?
T-minus 15 seconds.
If you want to feel what a space shuttle launch is like, you can go to space camp.
Or you can watch me fly a mission in a real shuttle simulator in NASA.
T-minus 10 seconds.
And Charlie builds a wicked rocket out of regular stuff. It's gonna be a blast. Blast off!
In 5, 4, 3, 2, 1.
Lift off!
We have liftoff of the program. Popular Mechanics for Kids.
Welcome to the Cosmodome, home of Space Camp Canada. This is a place where you can feel what it would be like to journey through space. Thanks. Up, up, and away!
Jay and I are experiencing what it would feel like to be weightless. This doodad is supposed to give you the feeling an astronaut has while moving around in space with a jetpack on her back. You have to get used to not being able to stop on a dime. Whoa!
This is supposed to simulate zero gravity. The chair is adjusted to fit my weight so that I get, that floating feeling. Now, my challenge is to repair the satellite in a zero gravity environment. Can't get it. Well, Houston, we have a problem.
Roger, Jay. This is Houston. We'll seek help.
Over and out. I'm here at the Johnson Space Center in Houston, Texas. This is the capital of space travel, the place where they design and test spacecraft, the place where they decide who the next astronauts will be and train them, and where you'll find Mission Control, the nerve center of the United States' missions in space. They call them extravehicular mobility units, or EMUs. I call them spacesuits. Whatever you call them, spacesuits protect astronauts from the deadly hazards of space. It's the only way they can stay alive outside of the ship. And I get to try one on here on terra firma.
I call that Earth. Hi, Alicia.
Hi.
Since the suit weighs 3 times more than you do, we'd like you to try it on piece by piece.
Okay.
Of course, in space, it would weigh nothing.
What's up with this? It looks like long underwear.
It is long underwear, except it's really special long underwear. See all this tubing?
Uh-huh.
There's enough tubing in there to stretch the length of a football field.
Jeez, why is that, though?
Well, we pump cold water all over the astronaut's body through that tubing.
Why?
Because the suit's a very good insulator. You know what a thermos bottle is like? It
Yeah.
keeps the heat in and out.
Yeah.
The astronaut would get very hot in here if we didn't cool him off some way. So this is the way we keep the astronaut cool.
It's totally freezing.
It's really cold, isn't it?
It's going all through the tubing. How do you get in here anyway?
You just need to wiggle in there a little bit more.
Okay. They call this part of the suit the lower torso assembly. I call it covering me from the waist down.
Okay, lift your arms up like you're diving into a swimming pool.
Hey, it feels really bulky in here. What's it made of?
Well, the suit's made of a number of different materials. Look, it's got 9 different layers.
What are they for?
Well, this first layer in here keeps all the gas inside. The oxygen that you breathe, you gotta make sure that doesn't leave the suit because you want to stay alive, right?
What would happen if you got a hole in the suit?
If the hole's big enough, you might fly around space like when you let go of a party balloon. Or the worst thing would be your blood would boil, and that's not fun.
Why would your blood boil?
Well, it's not from the sun. It's not a temperature thing. It's because all the gases in your body want to expand very fast. They want to rush out of your body.
So that's pretty dangerous.
Oh, it's very dangerous.
It takes a lot of help to get into one of these. Watch Phil as he pressurizes the suit, just like they do in space.
You gotta make sure you don't get the flag in your armpit. That's bad. See, Alicia, this is what it looks like when it's all pressurized. There's ball bearings in here that let me turn the joints. See how stiff it is?
That's very stiff. But I think we forgot one thing. Can you guess what this is? They call it a maximum absorption garment, but the rest of the world calls it a diaper.
So now you tell me.
But I guess when you gotta go, you gotta go. Most of the time, all we see are the triumphant moments of a space mission. But like most things in life, you have to learn from your mistakes.
No, dadgummit.
Often, it's the little things that trip you up.
Thing out now that I got it. I was rolling on the moon one day in a merry, merry month of December. May.
This is a real training facility. Every astronaut at some point has trained here. And NASA's given Popular Mechanics for Kids special permission to go through a real training exercise. This cockpit is identical to the one in the space shuttle. It's a lifelike simulator with all the same buttons, and I get to go up in a practice launch. And my job is to monitor any engine malfunctions.
Okay, Alicia, I'm going to play Houston Mission Control.
Okay.
And you're going to be the Space Shuttle Columbia.
Okay, what do I look for?
You need to make sure the 3 engines are running at 100%, and you do that with these 2 meters right here.
Okay, so I just keep looking to see if they stay at 100.
Exactly.
Okay, and they look like they're at 100?
Columbia, Houston, we have liftoff.
Trajectory looks good.
As you know, we run the main engines for 8.5 minutes before we reach orbit. At that point, we're traveling 25 times the speed of sound. There's 2 main fuels for the engine, and we're going to use helium to make sure those fuels stay separated.
And what happens if they mix?
Kaboom! The shuttle could explode.
The whole thing.
You've got it.
And everybody could die. So,
Exactly.
So I really have to work fast at this.
You've got it.
Okay, we look fine so far. Oh no, it's going up on the left engine?
Columbia, Houston, we're monitoring a helium leak on the left engine. Would like you to work the procedure starting at step 4. So that leak could be anywhere in this system.
So what do we do to find out where it is?
First, we want to check, is it in the A leg? Close this valve and see if the pressure drops. If it doesn't, well then maybe it's in the B leg.
And nothing's in the B. It's still not doing anything. Now what happens if nothing works?
In this case, you can't reach orbit, so you have to come back and land back at the launch pad. And that's what we train the astronauts to do in this case. Now, in real life, you did make it back safely because you worked the procedure very quickly.
Well, can we try it again? Can we do it one more time?
Well, unfortunately, we can't. We've got some astronauts that are waiting for their turn in the simulator, so we gotta go now.
Well, I had fun doing it.
Astronauts do a lot of training here on Earth, but how do they recreate weightlessness? They practice in a huge water tank with a full-size model of the shuttle. Or they take a trip on the Vomit Comet, a DC-9 which nosedives to make you weightless for 9 seconds. This is a multi-axis machine. It makes you feel disoriented. Let's see if Alicia can explain the rest. Ready?
Ready as I'll ever be. Ah! Astronauts get disoriented. Wah! Because there's no up and down or side to side. I can't see my headlights!
What she's trying to say is that astronauts get disoriented in space because there's no up or down. So they train on one of these to try to get used to that feeling.
Whoa!
Mostly they're trying to avoid space sickness. 3/4 of all astronauts get space sick. It can be a real problem.
Oh, good sensation.
To help people adapt more easily to life in space, a special mission called Neurolab is underway.
Hi, Jay. I'm Dave Williams.
Nice to meet you.
Pleased to meet you, too. And I'd like to
These
introduce
are
you
the
to my
astronauts
friends
on the
who are with us
Neurolab
today.
crew.
This is Jim, and we have Jay Bucky.
Great name, Jay.
So,
Hi,
Jay,
Jay.
I'd like you to meet Jay.
Thank you, Jay.
So that's pretty cool. So you ready to go, Jay?
I think so.
All right, we're ready to go. Let's go.
What the heck is this?
Well, Jay, this is really incredible. This is called the rotating sphere. And this is where we study something called vection. And that's a sense of moving when you're in fact not moving at all. I don't know if you've ever been in a car sitting at a red light, sitting there stationary and the car beside you moves ahead. What happens? You have a sense that you're actually moving backwards and you're not even moving.
Could I try it?
Yeah, I think we want to get you in there.
Woohoo.
So are y'all ready in there, Jay?
You betcha.
You're psyched? Okay, here we go. This is gonna be really cool.
Oh boy.
He's having a good time.
This is amazing. Wow.
It's incredible. He's spinning around and around and around. But you know, he's not moving at all. It's the sphere that's moving around and around.
I'm in heaven.
No, he's having so much fun in there. I think we need to take him out of here, bring him over to the space lab, and put him in the tumbling space lab and see what happens.
Space Lab would be an excellent choice. He'd like that
I
very
think
much.
The tumbling space lab works just like the rotating sphere. But instead of seeing black dots, the person sitting in it sees the interior of the Columbia Space Shuttle. The illusion is incredible.
Doing great, Jay.
Scientists hope to find a cure to the problem of motion sickness. It'll still probably take a while before all the results are in, but I'm in no hurry. Hey, Dave, you know, I could stay in here longer if you really need me to. Who knows? Maybe I could qualify for the program, and I could become the world's youngest astronaut.
Maybe they ought to fine people for littering in space. There may be as many as 35 million man-made objects in orbit around the Earth. Old satellites and rockets, even frozen garbage from the shuttle. All that space trash can be dangerous. Even a small piece can hit with the force of a bullet. It damaged the shuttle's windows. The shuttle has had to make 5 evasive maneuvers around space junk so far.
Welcome to Project Thruster. Thanks for coming. You're looking at materials I'm using to build the Charlie rocket. It looks innocent enough, but with these elementary household objects and this special engine, I will have achieved launch capability within the hour. I start with a leftover cardboard from a roll of paper towel. I will construct my fins out of foam core. I cut the fins so that whatever angle I make them, all 3 are identical. If I want my rocket to fly straight. I have to space the fins evenly apart. This has to be exact. Using a hot glue gun is the best way to attach the fins. Cut a cardboard roll with a smaller diameter. I took this one from a roll of plastic wrap. You can use it to attach a second roll. A longer rocket is more stable in the air. My nose cone completes the rocket shell. Now, to ensure a smooth return to Earth, I'll need this amazingly simple kitchen garbage bag. First, fold it in half, and then fold it in half again. Then cut diagonally. It gives me 6 sides when I unfold it. Attach very thin string or thread to each corner. And I have a parachute. I use a piece of elastic like this and fold the elastic ends into a piece of paper. Glue the paper to the inside of both the top and the bottom part of the fuselage. Connect the thread to the elastic and fold your parachute up. I protect it from the heat of the engine with a barrier of toilet paper balls. Otherwise, your chute would melt. Now I'll connect the fuselage. Always buy an engine that is certified for model rocketry. Insert into tail. Charlie was here. Woohoo! Now it's time for the launch pad! The technology for this launch pad comes from a hobby shop. I'll be sending electrical currents through these wires, which will create a spark in this ignition wire, which will light the gunpowder in the engine, and blam! The engine will explode and the rocket will take flight. A few words of warning. Always, always have adult supervision for this. Always launch in good weather, meaning little or no wind, and in clear areas. You'll notice I'm launching the rocket from at least 5 meters or 15 feet away. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's go! Look at it go! That is so cool! I gotta do this again!
In space travel, it's not efficient to use an engine for anything more than liftoff and minor course adjustments.
Sorry.
So, what keeps a spaceship moving? Gravity, the force that attracts smaller objects to larger objects and keeps planets orbiting around the sun. By orbiting planets and moons along the way to its destination, a spaceship is able to build up speed in much the same way as a slingshot works. Instead of moving in a straight line, a ship can coast without engines by orbiting the sun. And by moving from planet to planet, a ship is able to gain speed because of each planet's gravitational pull. By doing these things, a ship can travel a great distance without running out of fuel.
Earlier, you saw me fly a mission in an actual shuttle simulator at NASA. It took special clearance to get me in there.
But there's another way to feel that sensation of flying a real shuttle mission. The kids you're about to see did it at space camp.
You definitely have to work together because you can't get anything done if everyone's talking at the same time. We are just a few minutes away from resuming the countdown. Endeavour crew, please power up the orbiter's controls.
Houston, Endeavour, the flight controls and instrumentations are now operational.
This is mission control. In just a few moments, the shuttle Endeavour will be lifting off.
We're going into orbit to repair a broken satellite. This could be dangerous.
Roger, Endeavour, we confirm that all systems are now operational. Begin pre-flight operations.
Inco is go for launch.
Go for lunch.
Everything is A-OK and ready for launch.
I'd be terrified at liftoff. I'd be flattened against the seat and I wouldn't move.
I'd feel proud. I think I have the guts to go.
T-minus 10, 9, 8, 7. Main engine start. 4, 3, 2. Booster ignition and liftoff of the shuttle Endeavour. Endeavour has cleared the tower.
Roll maneuver start.
Engine's at 104%. I like the mission because it gives you a good feeling of how it is to be going in space.
Everything's true about it, you know, like everything's real.
Oxygen level is normal.
Endeavour, stand by for booster separation in 30 seconds.
Roger, Houston, SRB separation in 30 seconds.
Endeavour Houston, confirm SRB separation.
3 minutes to main engine cutoff.
It's tough out there. You can't have all fun.
My main goal is to be in the 4-person expedition to Mars in 2015.
We're in orbit at last.
See you in space! The space event of the millennium is the International Space Station. It's being carried up piece by piece in the space shuttle. They're putting it together in orbit, and in the year 2002, it'll be complete. Part of their training's down here, in the habitation module. It's a life-size model of their living quarters. And we're here to see how they live. Astronauts spend more time working on experiments than anything else, about 9 hours a day. Yes, I'm sleeping on the wall, and I'm Velcroed in so I don't float away. When you don't feel the pull of gravity, there's no up or down, or ceilings and floors. Eating in space used to be like squeezing toothpaste out of a tube, or at best adding water to dried food, but not on the space station. Most of the food on the space station is frozen and packaged in special containers so it doesn't float all over the place. And like at home, we zap it with the microwave, except this is a model and it doesn't work. Hi.
Hi, Alicia. How are you doing today?
Good.
Well, what you pulled out of the freezer was broccoli. And it's one of the most delicious items that we have today. If you want to try some of the foods today, you are more than welcome. We have fish.
Ugh, this kind of smells fishy.
How about the macaroni and cheese?
Yeah, sure, I'll try it. Oh, gosh. It's not that bad. It tastes a little tangy, but it's not bad.
Well, we had to reinvent the straw for the astronauts to use on orbit, because if you had a regular straw without the clamp, all the juice would float out and then you have stains all over the space station.
Right.
You also know they have special containers to hold their utensils, so they also don't float off.
Right,
It's a
kinda
little
like
rubbery.
rubbery,
Yeah.
Kind of squishy.
And you notice you left your fork there.
Yeah.
And now if that was in orbit, that would be gone.
To take a shower in space, astronauts use a sponge on a tube and smear it all over them.
And without gravity in space, Alicia, the water doesn't fall to the bottom of the shower. It beads up on the astronaut's body, so they have to use this other device. And guess what this one is?
Let me guess. It's a vacuum to suck up all the water.
Exactly, it's for water recycling.
Squeaky clean. Even in the toilets, they use restraints to hold the astronauts in place.
Actually, that's the most frequently asked question about living in space is how do the astronauts go to the bathroom? And the answer from them is very, very carefully. Those restraints are a key part. They help keep a tight seal.
And instead of using water to flush the toilet, they use air currents to dispose of you know what.
And don't forget this for urine collection.
Some privacy, please. Since the space station orbits the Earth every 90 minutes, I think I'm gonna kick back and enjoy the view. Hey, that's the radar alarm! Something's approaching! It's Charlie's rocket! Hasn't he had enough fun for one day? He's gonna get us killed! Look out! Oh, Charlie!
Charlie here. Sorry, guys. I didn't think it would actually go that far.